HVAC drawings typically communicate design intent, and that's because the non-graphical information is often more important than the graphical information. I mean, what's the use of an earth terminal with accurately modeled plenum box if the flow rates, configuration, and direction are wrong? And that is why HVAC designs typically come as single line drawings at the conceptual design stages. In other words, you don't need to model unnecessary details in HVAC families. You should also be able to turn details off and on as needed. In this video, we'll explore some Revit features that enables you to manage the level of detail in the Revit families and also tweak the graphical information based on the level of information needed in projects. So start by opening the two families you used in the previous video, or finish Earth Terminal and finish Equipment in the Chapter 2 exercise files folder. So at this moment, launch Revit, navigate to the exercise files. From the Chapter 2 folder, open this file, finish Earth Terminal and finish Equipment, which I already have open. First, we don't need to show the geometries of the Earth terminals on the floor plans. I mean, we can represent them with lines to boost model performance, just like we have here. So to achieve that, open the reference level view from the Earth terminal family, then select the Earth terminal and neck geometries and edit the visibility/graphics overrides from the properties browser. Uncheck plan/RCP and close the dialog. Next, go to the annotate ribbon and launch the symbolic line command. From the drop panel, activate rectangle and trace over the Earth terminals outline, locking the 4 lines. Then draw 2 diagonals from the edges. Tweak the Earth terminal dimensions to confirm that the lines flex appropriately. You can also toggle the preview visibility to glimpse what the family will look like in the project environment. Next, for the equipment, we don't need to see the host extrusions for the connectors on any view unless at a fine detail level. So to achieve that, we'll select the host extrusions and activate the visibility settings again. So there are 7 of them. We'll select them all. Confirm you have 7 items selected here. Then launch the visibility settings. Under the view specific display, uncheck plan/RCP, and under detail levels, uncheck grass and medium. Then click OK to close the dialog. You can also control the visibility of geometries through the visible parameter. So to demonstrate that, we'll select the 2 mount geometries and then we'll associate family parameter to their visible parameter here. We'll create a new yes or no parameter called show mount. Then we close this. You may also want to modify the graphic properties without affecting the whole component. In that case, we need to create a subcategory for the geometries, and this is typically used for clearance zones. So to do that, we'll go to Manage ribbon and launch the Object Styles dialog. Then we'll create a new subcategory. We can call this Equipment Mount for now. Then we'll select the parts and assign them to the subcategory from the properties browser. So we'll just select the 2 Equipment Mount geometries once again. And from the properties browser here, under the subcategory, you see the Equipment Mount from the drop down. So now when you load this family into a project, we find the subcategories under the parent category and you can modify their graphic properties independently, both from visibility graphics overrides and object size. So this is the same family I have here in this test project. So when I launch the visibility graphics by typing VV or VG, and I go to mechanical equipment category, when I expand this, you will see this under the parent as a subcategory, and now I can override it independently. The same applies to object size. So when I go to the manage ribbon under this settings panel, you see object size, and then when I go to mechanical equipment, you will see equipment mount as well, which I can adjust the graphics independently. So the next thing we want to do is to embellish the 3D geometries in the air terminal family with 2D details for the airflows. So if you look at this, typically for air terminals, they come with these arrows indicating the direction of airflow in the spaces. So for us to achieve this, we'll be open the air terminal family and load the 2D detail family in the chapter 2 exercise files folder. So go to the insert ribbon and load family, navigate to exercise files and load this family duct terminal arrows. Then from the project browser here, expand the family tree, and under detail items you will see the family. We'll need to place 4 instances along the center reference planes. This way you can use the mirror command, make sure copy is checked, and create 4 instances along the center reference planes. Now select one of the arrowheads and click edit type to launch the type properties dialog, and associate the length parameter with a new parameter named length as well. Notice that the data type here is duct size. So group this under order, and then we'll close this. You can also change our scale. So next we'll launch the family types dialog and set the formula for this length to a conditional statement that maps the arrow length to the longer side of the air terminal. So simply type this formula here: if diffuser width is greater than diffuser height, use diffuser width, otherwise use diffuser height. You need to make sure that your spellings are correct. Now you can see we have this mapped to the diffuser, so whichever of these two that is longer, it will take up the value. So if you change this to 400, this will become 400. Also because this is already mapped to each other as well, so they are always the same. So but now you can see that that controls this. So also we'll create 2 length parameters named width 1 and height 1. We'll also group them under order. So we'll call this width 1 grouped under order, and height 1 grouped under order as well. Then we will set the value for this to diffuser height times 0.65 and diffuser width times 0.65. So what we're trying to achieve here is that the dimensions of this diffuser or the air terminal controls both the length of the arrowheads and also their distances from the air terminal. So for us to achieve the distance, we'll close this. Notice that this adjusts in size. So we need to dimension this our arrowheads to the center reference planes. So quickly do that. Then we'll assign the horizontal dimensions to width 1 and the vertical dimensions to height 1. So now as we adjust the size of the air terminal, it affects both the placement of the arrowheads and also their distance. So if I change this to say 400, see that everything adjusts accordingly. So finally, we will need to associate family parameters to their visibilities as well. So we'll select each of these, and for the visible parameter, we'll associate family parameter. For this, we'll call it upflow arrow. For each of these, we'll make it an instance parameter grouped under mechanical. So this is right flow arrow, instance mechanical, downflow arrow, and left flow arrow. So finally, we'll open the family types dialog and confirm that all the parameters flex appropriately. So when you click on family types, you see all the parameters we've created so far. So you can adjust these as necessary to confirm that everything works as fine. You can also do the same for this. You see all the parameters created so far. So now what we have here is a supply diffuser. We can also create a return diffuser out of this. To do that, we simply go to File, we save as family, and you can just give it a convenient name. But when you do that, you need to also configure the connector properties and the other parameters accordingly based on everything we've learned so far in this chapter. So for example, when you select this connector, you need to make sure that the flow direction is out and the system classification is return air. Also, you need to flip these arrows accordingly. For example, when you check this, you see the right flow directions. This is supply, this is return. So you can compare the results with the completed families in the chapter 2 exercise files folder. So these are just some features for managing the level of detail for Revit families. We've talked about symbolic lines. So you go to annotate ribbon, see symbolic line. We've talked about visibility graphics overrides. So when you select a geometry, you can modify the visibility graphics either from the ribbon or from the properties browser. We also talked about the visible parameter. So you can map the visibility of a geometry with a yes or no parameter. And finally, we talked about the 2D details, which you can create with either a 2D detail family or annotation family. So with these, you can now create and modify HVAC Revit families to meet the level of information needed for your projects.